Hi there, I'm glad you're here. It's Alex from Shelf 12. It's Wednesday, February 24th, 2021. In the last video, I mainly concentrated on improvements in character movement process and partially implemented all of this stuff using a self-made entity component system partner implementation in Godot. Also, I started to figure out how UI was working, and I added a turn-in button. There are not a lot of obvious improvements this time, but I think they are pretty important too. First, I remembered that I was influenced by board games, so using a tile-based map was a reasonable option. There are two typical shapes of tiles, squares and hexagons. It's clear that squares are easier to program and store, but hexagons look a lot better on the table. So I picked up the hexagons. At the point, I didn't know how complicated the implementation was going to be. I spent almost 5 hours trying to find the right formulas for hexagon. At last, I found a terrific article about hexagon grids, and it stopped my misery. It also took an hour to find a good proportion of the hexagon's width and height. I was pretty happy I put it in a global setting, because it would be easy to readjust if I were to change it in the future. What do you think? Is that a nice shape? When you create a hexagonal grid, you usually use an irregular coordinate system, but it still has two axes, R and Q, and they aren't perpendicular. Besides that, the scale of this axis isn't the same. It doesn't make it hard for machine to calculate, but it makes it harder for me. And while the conversion from axial coordinates to pixels wasn't a complicated process, the inverse transformation has been tricky. But this transformation is very important, since it's a part of a mouse-click handling process. When the user clicks a point on a map, this function transforms the pixel coordinates into axial coordinates and rounds it to the nearest hex. It allows the goal marker and character to be positioned right in the middle of the hexagon. From a technological point of view, I realized this week that I would have a dynamic scene, and most of the objects would not have been specified in the Godot scene before the application began. For example, the number of enemies or the allocations wouldn't be the same for each round. So I have to handle these objects in runtime, and it's going to be extremely good to distinguish the logic of the game from the logic of visualization. Especially if I add multiplayer experience, create files to save the progress, or do some AI programming. That's why I divided my implementation into two parts. The presentation part, powered by the Godot entity component framework I wrote last week, and the game logic part, I had been working with this one. These two sections are loosely coupled and communication is organized in a string format, so it will be easy to use HTTP or TCP transport instead in the future. There is a lot of insightful technical details to share, but it's too boring if you are not interested in it. So I'm going to save it for a dedicated video. Please let me know if someone interested in it in a comment. And there is not a lot of changes to the mind map. This week I chose to use tiles and even started implementing a hexagonal map. Next, I'm going to make it easier to find a route and avoid obstacles. So I hope the character movement part will be done soon. And that's it for today. I will continue to provide you with weekly updates. So if you have any ideas, please feel free to contact me. Thanks for watching.